MediaWiki on Kubernetes. I am still Hecht, still, to the best of my knowledge, CEO at WikiTech. We're going to talk about a very complicated topic. Not MediaWiki, Kubernetes. It's way more complicated, although MediaWiki is complicated enough. So I'm going to try and give a basic understanding of Kubernetes, very basic, because I don't really understand it fully myself. What is Kubernetes? So this is about how I would explain it, and I think that should clear everything up. It's basically the same thing as K8s. It just got more consonants. So if you see that term around, it's Kubernetes. And it's an orchestrate, whatever that is, platform for containerized apps. So basically, you'll take an app. It could be MediaWiki. You put it into a container, and you put that into a nice little pod, and then you have Kubernetes that will be controlling that pod. It'll be watching it. It might be fixing it. And Kubernetes is basically the manager. So all of your applications are being run. It could be multiple applications, multiple parts of an application. They're all being deployed in different pods. And it's the one that's controlling how many pods you have. You can have multiple pods. You can have multiple nodes. We'll talk a little bit more about that. It's essentially the manager that controls all that, and it can make the nodes larger or smaller, give you more resources, less resources, replicate things like that. So to put that into a very simple example, so I'm running my presentation now, and I'm very nervous because I'm a little bit worried. Let's say this is my laptop, and I'm a little bit worried that something might happen to it. It could fall down, and then my presentation is done. So instead of running the presentation from here, I'm like, you know what, Mark, can I know you have a very powerful laptop there. Can I rent for like the duration of the presentation? 2 gigabytes of RAM, 2 CPU cores, $5. So Mark readily agrees. And I'm like, okay, awesome. And then I'm like, okay, but I see Mark's got something in that thermos there. I'm not sure what it is, but whatever it is, it might spill over. Sure it is. It might spill over, and that's the end of the whole idea. So like, okay, Scott, $5, same deal, all right? And now, Kubernetes basically says, okay, instead of running off of this laptop, we're going to run the presentation off of these 2 laptops. So that way, if something happens to one, we got another one. We're always going to have 2 there. And I'm going to be like, okay, Cindy, you 2, all right, just in case. Because I always want to have 2. So if Mark gets bored and he leaves, Kubernetes says, well, I know I always want to have 2. And now I have 2 laptops to run it on. So in this example, my software that's running a presentation would be a pod, okay? The pod would be deployed onto my node cluster. These 3 laptops are my node cluster, and each individual laptop is a node. So I can put my presentation on there, and if one of them fails, I can just go there. And if I'm like, okay, this presentation looks like it might need more resources than I thought, so I'm like, Mark, I want to double that. $10, double it. Mark says, okay. I double everybody. So that way, no matter how complicated my presentation gets, it's going to be able to scale up. And I have that 3rd pod from Cindy, so I can actually scale up, and I can use Cindy's and say, you know what, I'm going to use all 3 of these nodes for my presentation. All right, a very simplified example of Kubernetes that is not 100% accurate, but hopefully gives us a basis that we can move on and understand the rest of the presentation, hopefully. The Kubernetes ecosystem. So if you're familiar with Docker, you can understand this analogy very well. Docker is just that. Kubernetes is that. But it does give you a lot of tools. It's very popular. So people have written some awesome tools that do automation for you. Argo CD will allow you to do things like GitOps, deploy your code automatically. Backup. So there are backup tools that don't run on Kubernetes, but there's also really good ones that run on Kubernetes. They're very well automated. Great ways to observe. So in that example, Kubernetes actually is controlling everything. It's the hidden force in the room that's like moving things around and making things bigger and smaller. You still need a control plane. So this laptop here is going to be my control plane, and it's going to be receiving signals from here saying, this is the traffic that's being served, this is what's going on in these individual laptops, and it's going to be writing those logs, the monitors, whatever it is, and it's going to be observing and watching what's happening. And all of this is controlled by Kubernetes, just orchestrating everything. There's also Helm charts. Helm charts, you can think of them like recipes, how to deploy individual apps on Kubernetes to make it very simple. I just have an app, I'm like, okay, I'm deploying it, it's got the recipe, and Kubernetes is happy, and it deploys it wherever it's supposed to be, how it's supposed to be done. So you've got the management of the pods, you've got self-healing, so this would be sort of like a bobsled team. So you have your bobsled team, it crashes, so you got to have one guy on the team be like, hey, you dead? Right? And he says, no man. So that is a liveness probe, okay? It's Kubernetes saying to each of these nodes, are you still alive? And they're like, yeah, still here. Right? And if Mark decides this presentation is ridiculous, walks out, it's going to be like, nope, not here anymore. Or if something crashes on Mark's laptop, it's going to be not going to respond, so it's going to restart Mark's laptop, and it's going to be able to keep on serving things. And also, there could be multiple pods running on, let's say, one of these laptops. So I don't want one pod to take up too much of the resources, so it'll put some caps on it and make sure that everything that's running on this node has all of the resources it needs. All right, this is a big problem I wanted to talk a little bit about. So I'm going to talk about moving from your standard VPS. We're moving to Kubernetes. We're not using Docker Compose, but we're going to use a single node Kubernetes cluster. It looks like this. I had a VPS. Docker Compose was running in it. I'm like, okay, I want scalability. I want high availability. I want all those goodies and liveness probes, all that good stuff. So I'm going to put a Kubernetes cluster inside this VPS. So the problem is it's still inside a box. It would be like running a Kubernetes cluster on only Scott's machine. It's good, but like if something happens to the machine, that's a problem. And also, I can't get bigger than Scott's machine. It's a really nice machine, but like if my presentation gets really big, I can't go anywhere. There's another problem, which is the I/O bottleneck. There's only one laptop in each of these machines. So every single one of these pods, no matter how many I have, they're all using this one pipe. So if one of these is doing a very complex operation, this is going to get slowed down, and there's absolutely nothing I can do. I can do whatever I want with these pods. I can scale them up, I can scale them down, and to a certain extent, I can even somehow move it to a bigger VPS. I'm still stuck with one pipe. And if I'm running a big database backup, then my web server is going to be physically lagging, and really for no detectable reason. I'm going to be looking at it, I'm going to see the server load is going up, CPUs are going nuts. What's going on? I don't understand it. I have this really, really nice VPS, very powerful. It should be able to handle this, but it can't because of this problem. And you have the box. So we were talking about problems with AI crawlers. So I'll take a little bit of a sidebar. I know I'm running out of time, but a little bit of a sidebar. We discovered that when we were running individual servers or VPSs on dedicated servers, when the AI crawlers hit, the servers went down. And it was like, wow, look at the CPUs. They're going crazy, right? And we put all kinds of things in place to try and stop that. We have some blockers that are learning patterns and figuring out who to block. And we've got multiple layers of caching. And all those things help a little bit. but we were not addressing the fundamental problem. And we did a lot of checking and monitoring and everything else, and we found the reason that everything we were putting in place, increasing resources, throwing massive servers at the problem, what really the problem was, this guy. It was basically the input-output. And no matter what we did, you can mitigate the problem by adding caching layers and blocking bots and everything. This is the real problem. And until you address this, you still have a problem. And what we found, I'm just telling you our experience, when we started, almost a year ago, we started moving our clients from single VPSs onto our cloud Kubernetes cluster, they stopped going down. Just telling you that's what happened. All right? We were still getting the same level of traffic, the same bots were bothering us, but they weren't going down. And we believe that it was because of this. All right? There are other advantages of Kubernetes and the scaling and everything, more resources, shared resources, everything like that. But we really believe this was the main issue we solved.
So your diagram implies that your production server has a single spinning hard drive, but what if you have like RAID 6 NVMe SSDs? Do you get the same issue?
I don't know. The question was, if you have basically multiple hard drives running instead of one, do you still have the same pipe? The answer is I don't know. This VPS example is where the disk is actually inside the VPS. If you had an external disk, it would help. Even one external disk, I think could help this to some extent. But, okay. Never use a single node in production. That's a good rule to follow. That's Kubernetes. That's your single node. It's not a good idea. You're like, hey, I want Kubernetes. I get high availability. Well, the problem is, as we said, if there's a problem with the hardware or there's a problem with the software where it just crashes, then you're out. And because you're using Kubernetes, and it's really powerful and all that stuff, so you have a lot of overhead that you wouldn't have with Docker Compose. So you have limited resources, plus you have many more things that are competing for those resources, so that can cause major problems. Also, managing Kubernetes is expensive. It's expensive in your time, and it's expensive in, you're going to have to pay somebody potentially who really knows this stuff in order to manage everything. All for what? A single node cluster. And remember we had the control plane and we had the individual nodes? Well, what if the control plane is inside the single node? So everything is running inside one box. So great. The control plane is asking all the little pods, are you still alive? And they're like, yeah. Great. Until the control plane dies. So if you run out of memory, it may not kill one of the workers. It may actually kill the manager. And now what's going to restart anything? So this is an illustration of basically moving to multi-nodes. You have multiple ways to get disks. So you solve the I/O issue. You missed it, but I was talking about how this solves a lot of the bot problems, having multiple I/O lanes, high availability. If one of them dies, you would barely even notice. If one of the nodes in the cluster dies, it just moves everything. And storage redundancy. So the best thing is actually, if we had this little node cluster, we wouldn't be using any of these hard drives to store anything permanent. The hard drives would actually be in the next room. And therefore, whatever happens here makes no difference. And that is the ideal of statelessness. Everything's great. It doesn't matter what happens here. We'll just get more laptops, and all the data is safe over there. And anything that's stored in the internal hard drives is temporary. We can just redeploy the cluster in new laptops and like nothing happened. So everything is living outside the cluster. That's the autoscaler. Horizontal autoscaling would be moving things in between the laptops, deploying another laptop, maybe buying another one. And then node pool autoscaling would be increasing the resources within each laptop. We want more memory, we want more CPU. For MediaWiki specifically, so you can move different components of MediaWiki into their own pods. So for example, run jobs should definitely be on its own pod. And that way, it could be doing its Elasticsearch thing, Elasticsearch write and write and write. and it could be doing millions of them. It wouldn't make the slightest difference to the web app. It's still going to keep serving like before. There are also other things that you can move. Redis can be moved, and Varnish could be moved. All those things could be on separate pods. You could have multiple copies of them, and you could have them on completely different hardware, and therefore your server will be much more reliable. The problem with MediaWiki is that the local settings are stored in a file, and that makes it very awkward for Kubernetes. There have been multiple extensions that have tried to solve it. None of them have solved it. I know this thing's in the works. Until that's done, store your settings in a database, and we use this as the solution, where basically Argo CD injects the values into local settings. There's another problem that you end up with, which is when you run upgrades, you have race conditions. Basically, you have to run update.php when you run an upgrade or some extension installations, and that means you got to operate on the database. If you have 10 replicas and they're all trying to run update.php, you end up with this, a big problem. And the way to solve that, one way to solve that is with Argo CD, where basically you have the old software running on some of the pods, reading the database. You have one pod that updates the database, and then once the update is completed, now the 10 new versions of MediaWiki are rolled out. And of course, that requires that the old version and the new version are able to read it, read the same database. That's what it looks like. And we are launching cloud.wiki. So we already have our Kubernetes cluster. This is a basic example of what's going on. And we have our clients on it. But what we're launching is essentially a software as a service platform where you can visit cloud.wiki and you can actually just fully order yourself a very, very simple process to get a very complicated setup. You don't have to worry about Kubernetes, and it will give you a top-tier production-grade environment. It will stay up, it will be reliable, super fast, essentially what we already have, but brought to everybody, essentially. You can run Canasta, you can run Takasta, you can run BlueSpice, whatever you'd like to run. Thank you very much.
Thank you, Ike. We're running a little bit late. I don't know if we have one. Oh, you can ask him a question anytime. Would you like to answer a question from Daniel quickly?
No.
Oh, wait, no.
Yaron, go ahead.
Yaron has a question.
Okay. Well, you said Kubernetes setup was complex per installation. Sorry, thanks. You said Kubernetes was complex unless, of course, you have a software as a service setup or something. Does it have to be complex? I mean, isn't there a way to have the process be automated of creating a Helm chart or whatever it is based on the exact environment that you're setting up in?
There are ways to make it easier, but you're still going to end up with a Kubernetes cluster, and just managing a Kubernetes cluster is a massive headache. I mean, it's like Docker Compose, but much more complicated. So you're going to have to know a lot more concepts and be able to, you're going to have to be much more skilled to manage a Kubernetes cluster.